Welcome back. Today I'm going to introduce you to expressions and talk to you about evaluating expressions. Okay, so we have a lot of notes today because it's the first time I'm talking about expressions, so we have a lot of vocabulary to attend to. So an expression is a mathematical phrase that contains numbers, operations, and or variables. Okay, so there's two types of expressions. There's a numerical expression and an algebraic expression. A numerical expression contains only numbers and operations, while an algebraic expression contains at least one variable. So this right here is an example of a numerical expression, where an algebraic expression is this one down here. So a numerical expression contains only numbers, so 4, 5 squared, 10, 6, and operations we have plus, squaring, minus, squaring, cubing, whereas an algebraic expression contains at least one variable. As a note, when we say that two algebraic expressions are equivalent, they're equivalent if you can go from one to the other using the distributive property, the associative property, or the commutative property. So that's one definition of equivalency. So we are going to be focused a lot in this module on making equivalent algebraic expressions. And what that's going to mean is using these properties, the distributive, commutative, and associative, to do things like combine like terms, distribute, and things like that. So we're talking about these three main things, both the associative and commutative properties of multiplication and addition. When you are working with algebraic expressions or polynomials, the only thing that you're going to be able to do is evaluate and simplify them. You cannot solve, okay? The word solve is used for an equation, so you cannot use them when we talk about algebraic expressions because expressions do not have equal signs. So evaluating is finding a value for the expression. Note, when the expression has variables, you must be given the value that is to be substituted in for the variable in order to evaluate the expressions. All right, so we have two examples here. So if I'm asked to evaluate an expression below for the value n is equal to 3, then every time I see n in the expression below, I substitute it for 3. So notice when I substitute 3 in for n in this situation, I have to write the multiplication symbol because here I don't need to write it because we have a constant or we have a number next to a variable. Here I do have to write it because now we have two numbers next to each other, so if I didn't write it, the number would look like 53. Okay, so we're going to use our order of operations. Let's evaluate inside the parentheses first. This is 15 minus 13 to the third. So this is 2 to the third times 3. Well, 2 to the third is 8, so we have 3 times 8, which is 24. So the answer here is 24. So the first thing you do is you substitute the value in for the variable. Okay, and then you start to use your order of operations to reduce it. Now, you might have seen this in 7th grade where this is a funnel shape because every step you're reducing it by at least one operation. Okay, example number 2 is a little bit more complicated. In this situation, our variable is negative, and we have to substitute it into this expression right here. So let's be very careful when we substitute it in. Whenever we see x in the expression, we are allowed to put in -2. Okay, so let's look at what we have here. Let's find our x's. I know this seems a little silly, but this is our x right here, and this is our x right here. So we're going to put -2 in this spot. So essentially what we're doing is we're going, this is outside that spot. So we have this, and we're going to put, so these are like where our x's are. This is the blanks where our x's are, okay? So in these spots right here, we are going to place in -2. So what we essentially have is we have, okay, let's put parentheses around here. We have -2 to the third power. Notice that x is being raised to the third power, and then it's being multiplied by -1 essentially. There's no parentheses around the x, so we're going to assume that they didn't want the negative x as a base. We're going to assume that what they wanted as a base was just x, but our x is -2. Okay, then we have minus, and again our x is -2, so it's -2 as a base to the 5. Okay, So I know that it's a little bit complicated, but if you think about it, really all I'm doing is putting -2 inside of these parentheses here. Okay, well, -2 to the third power is -8, minus -2 to the fifth power is -32. Okay, so this right here, this is like saying -1 times -8 minus -32. Well, -1 times -8 is just 8, and then minus 32 gets plus 32. So really, this answer is 40. Okay? And it's sort of surprising to get that because there was a lot of negatives in our original statement and everything sort of turned positive here. But make sure that you write this down carefully, and the reason why we're substituting, because students often have a difficult time substituting in a negative value when there are already negative signs present. Okay, especially negative value, raising it to a power. So if we had an expression with like, if I said substitute x in here, we have -x minus 3, and I substituted this x in here, we'd have this sign, here let's put it in a different color, this comes with this, okay? But then the x by itself is -2 minus 3. So this would be negative, the opposite of -2 would be +2 minus 3, which would get you -1. Okay, that's this expression evaluated for -2. Finally, we're going to talk about evaluating in a formula. So let's say that we have a situation where Sheila drove for 6 hours and covered 75 miles. We want to find the average speed for the first part of the formula. Well, rate is equal to the distance traveled over the amount of time it took to travel. So it looks like she drove 75 miles. So this is rate, okay? I know this looks like an equation because it has an equal sign here, but what I'm really doing is I'm substituting the value into the right side, okay? Distance over time. So distance over the 6 hours, okay? So 6 goes into 75 once. So we get 15, that's 2 times 12, so that would be 12.5. So the rate is 12.5 miles per 1 hour, or the speed, we can think of it as 12.5 mph, miles per hour, right? That's it. That's the end of the lesson for today.